We are now going to do this second and final part of the weather station assembly. We have the materials left over from the construction of the printed circuit board. We have the printed circuit board itself with the lead attached, which will go to the solar panel. We have the solar panel, the lithium-ion cell, two little hinge pins which will be used to mount the solar panel to the lid of the box, and a tie wrap adhesive mount which we will put on the side of the box to hold tie wraps. The tools we need is a permanent marker, a 1/8 inch and 1/4 inch drill bit, and you can use an electric drill, but a hand drill would be just fine. We need a Phillips bit, which can also fit in the same handle. We need a hot melt glue gun and our soldering station. So to begin, we are going to drill some holes around this portion of the box that the lid rests upon. And you'll notice that it's actually a double-sided edge. If we drill through the outside and the inside outside hole will be covered by the lid, but the inside hole will provide ventilation through the box. So we're going to put 6 on each side between these webs that are molded into the box. And you can do that by hand with the 1/8 inch drill. That's one. You can see the hole from the outside. There's some spool on the inside which you might be able to get rid of with the drill bit. And notice how it will be covered by the lid, but still have air access through this web. Let's go ahead and do the rest. Alright, I'm finishing up with the last 2 holes here. Really only took a couple minutes to do this. Let's clean up some of these holes from the inside. Might just be able to break off the spool. An X-Acto knife would also help clean that up. Be neat. Well, even though I did not say that you needed an X-Acto knife to as a tool here, let's get mine out and use it to clean things up a bit, if I can find it. It's really only the inner hole that has to be cleaned. There, that makes quick work of that. Alright, now I have a nice neat job. Now, we are going to mark the location of the printed circuit card. And you want to put it in a corner of the box with the USB ports pointing toward the middle of the box so that you have access with the USB cable. And you can simply hold the printed circuit board there with your finger and mark the center locations of the spacers with a little black dot. Now take the board out and we're able to see those black dots here. And what we're going to do is put a dab of hot melt glue at each location. And I just ran out of glue. Alright, got the glue gun working again here. We'll put a little dab of glue, hot melt glue there on that dot. And on this one. Back in the corner here. And finally this dot. Now, without wasting too much time, you want to put the board in the proper orientation into those puddles of glue, and in about 30 seconds it will be dry. Look at that. Now we'll take the screws out. And we have the mounts for the printed circuit board fixed in place in the exactly correct locations. And neatly done. So, now what we want to do is drill some holes in the bottom of the box for ventilation through the floor. And we're going to try the 1/8 inch bit first. If it's too much of a step to drill the 1/4 inch bit right off, we can make pilot holes with the 1/8 inch. But the printed circuit board will be in this area, so we're going to drill some holes here to miss the printed circuit board. That's good. This is a 1/4-inch bit. And that's a bit tough going in with the 1/4-inch. Let's go in with the 1/8 inch first. Put it in the middle of these diamond-shaped features of the box. Let's do some more here. Okay, these will be pilot holes for the 1/4-inch drill. Works. Well, we're going to need to X-Acto knife to clean these things up afterwards. And the last hole. Now you want these holes in the bottom of the box. You don't want them in the side of the box. Rain could be driven in from the side, but it's less likely that it would come up from the bottom. Let's go through here with our knife and do some cleanup. And I just discovered that plastic is very soft. The knife will cut it up if you're not careful. So we're just using a knife here to trim the flashing off of these drill holes. See, gentle job here. Not strenuous cutting. Let's see if we can get rid of that with our fingers. Nope. How about from the other side? There we go. Well, we're making a mess here. Work in a place where you can contain the mess and clean it up after you're done. So we have the bottom of the box finished. Now, to look ahead, we're going to be putting the cell here, the LiPo cell, reinstalling the printed circuit board, connecting the cell to the terminals, and we'll be running this out to the solar panel mounted to the lid of the box. And that's what we're going to do now. We're going to take the solar panel. Let's clean up the work here a little bit. Solar cell, the solar panel is going to be mounted like this at an angle to the top of the box, and we'll use the hinges to do that. So what we want to do is locate the hinges, and what you can do is just push them up to the edge of the box, and we're going to draw a little line where we want them to be. There's one, and here's the other. Make the line run the length of the pin, and we'll put a little line of glue on that. And then we will mount the hinges on that. Doesn't matter if you get any glue on the hinge pin itself, because these hinges will not be functional when they're in place. They're just there for support. Make them nice and square, and let's let them dry. Meanwhile, we'll take the protective coating off the printed circuit, off the solar panel. And let's do a test fit. You can have the solar panel rest against this raised edge of the box. That might provide some drainage. And here it is from the back. So what we're going to do, these are pretty well fixed now. We're going to put some hot melt glue on those pins, hinge pins, on the surface that the okay, my glue gun's giving me trouble here. There. I'll get a little more glue on there. Alright. Now we'll put the panel in place. You have a few seconds to adjust this. That's about it. Just a few seconds. Press the hinge pins against the back of the panel, and there we are. Not bad. So now we work on our printed circuit board again. Seem to have lost a screw. There it is. Another little piece of plastic flashing I'll get rid of. All right. We want to very carefully remove any protection that may be on the wires here of the battery. You don't want the positive and negative wires to touch each other. The battery probably has some charge in it, and we could get quite a high current discharge, which may trigger the built-in battery protective device, and we don't want that to happen. So these wires are pre-skinned, but I'm going to very, very carefully skin a little bit more. You just nick the insulation there. You might even be able to pull it off with your fingernail because the wires are very small. Using the diagonal cutters just to nick the wire. We go back to our Phillips screw and open up these terminals, screw terminals. When the screws are pretty much flush with the top of the terminal block, they're as open as they will get. Now, one is marked positive, the other by default is negative. So we want the red wire to go into the positive. So, oh, by the way, turn the on-off switch to the off position. The off position is not marked, it's the opposite of the on position. We put the wire in there and tighten up the terminal. And it looks like we might need a smaller, somewhat smaller screwdriver. The wire should be tight, and that is not. Let's try this again. Make sure you get the wire in the opening, closest to the center as possible. It is still not tight. Tight. So it takes some work there. That is tight. So let's put this back here very carefully. Try not to disturb the wires. The cell could be out like that, or it could be underneath the board. Here's where the pointy nose pliers come in handy. Pick up the screw by the pointy nose pliers, drop it in place. You can do the rest at the same time. Just make them slightly loose there first. this one. Whoops. Dropped it on the floor. Well, that will happen. So don't work over a subway grate. Alright, these just have to be what we would call finger tight. Snug, but don't crank them in there. Now, we'll take this wire, the cell wire, and bend it over the edge. And put the lid on. And you can press that down a little bit. It might bulge out a little bit there. Latch it in place. You want to form this wire into a sort of a drip loop so that when it rains, the water will drip down and drip off the bottom rather than running into the box. On the back side, we're going to solder the red wire to the plus and the black wire to the minus at the terminals in the middle of the board of the thing. And first off, just put a little dab of solder there and do this very gently. Use the minimum heat and the minimum time possible. And now I'm going to solder the wire in place. Might be easier if you take the lid off when you do this. Try to make the wire go down now. I think I'll keep the lid on so that I can maintain the proper orientation of the wire. Red to plus, black to minus. These wires were pre-tinned in the PCB construction phase, but if they're not tinned, you should tin them before you do this step. Here we go. Positive is in place. And now the negative. And I think it would be useful to inspect those joints, make sure they're nice joints. This one, the wire came up a little. You might have to hold it down with your screwdriver. And since these are exposed to the weather, let's put some hot melt glue over them as protection. And we're also going to put a little dab on the wire to hold the wire against the solar panel, just as kind of a strain relief. And there we are. I'm unplugging my hot melt gun. The box is complete. And now we need to run the program the software. I don't know if you can see it, but when I face the solar panel to my window here, the orange light is lighting up, showing that it is charging the cell. When the cell is fully charged, then the orange light goes out, and there's a little blue LED next to it that will light up to indicate it is fully charged. So it's working. Let me pass my hand in front of it. It really takes very little bit of light to charge it. You see that? The light getting dimmer as I cover the panel. It's not a particularly bright day. I'm indoors behind thermopane tinted windows, and yet there is plenty of light there to charge the cell.